Hey guys, this is Math 1513 College Algebra at Northern Oklahoma College. We're on Chapter 4, Section 3. We're going to talk about logarithm properties. I like to call them tricks. Alright, I'm just going to show you some tricks you can do with logarithms to help solve them. Okay, the first one is the product property. It just says that if you take the log of a product is just two numbers being multiplied together. So if I take the log of 3 times 4, that product, if I need to, it's okay to write it as the sum of two separate logs. Like this, log 3 plus log 4. And this is something you can check on your calculator. Remember, these are base 10. Those are common logs. We don't write the base 10 because they're common. So I just wrote a couple base 10 logs here, and just so you can check it on your calculator. So check that. See if log of 12, this is actually log of 12. I just rewrote the 12 as 3 times 4. See if the log of 12 is the same thing as log of 3 plus log of 4 on your calculator. The next one's the quotient property. So if I have the log of a quotient, that's two numbers being divided. If I have the log of a quotient, it's okay to rewrite it as two logs being subtracted. Now notice I made this one base 5. I'm just trying to show you that these properties work with any log, any base, okay? They work with natural logs, they work with common logs, they work with logs of different bases. So log base 5 of this quotient, 12 over 5, is the same thing as log base 5 of the 12, the top number, minus log base 5 of 5, the bottom number. You'll get the same answer. Okay, and the power property, this is the one I probably use the most. This is probably the one you'll use the most. It says it's okay, if you're taking a log of something that's being raised to a power, it's okay to take that exponent and move it up front as multiplication. So it's okay to rewrite this as 3 times log 10. I made this a common log again so you can check it. So put in log 10 put in log of 10 raised to the third power. So put that into your calculator. It's a common log. You can put it in your calculator and check and see if it's the same thing as 3 times the log of 10. Work those out with your calculator just to verify to yourself that this property is true. And the change of base formula is real handy because if you see a log and you don't like the base, maybe it's a base 4 or a base 6 or something you can't put in the calculator, we can change that base to a common log to something that we can put in the calculator. So for example, if I have this nasty log here, log base 7 of 5, well base 7 I can't put in my calculator. But if I rewrite it as log of the big number, 5, over log of the small number, or base 7, write that regular size. Now I've changed them both to base 10. Remember, we don't write the base 10. It's a common log, but I'm going to go ahead and write it this one time. We change them to both base 10 and take the log of 5 over the log of 7, and we can actually plug that into our calculator. So grab your calculator, do log 5 divided by log 7, and I got about 0.8271. So if you have a log that we can't put in our calculator, all you do is just change the base, put the log of the big number over the log of the small number. Now we can put it in the calculator. Now we can arrive at a result. All right, let's look at one like this. It says expand the logarithm. Now it's a natural log, but we can apply those properties to natural logs as well. Expand just means write it out as a bunch of logarithms. So we'll be using addition and subtraction and some other stuff to write it as like 3 logarithms. Okay, my first step is I see a quotient there. I see the top number being divided by the bottom number. So I'm going to rewrite that as the log of the top minus the log of the bottom. Okay, now before I go into this next step, let's have a little review about how to write roots as the base 4 raised to a fractional exponent. Well, look at this over here. This 4 is being raised to the third power, and we're taking the square root of the answer. Now, square root has a little 2 there in the root. We just don't write it. We use it so much we don't write the little square root. So 4 is being raised to the second power, and we're taking the second root of the answer. Another way of writing that is 4 raised to the 3 over 2 power. Notice that my power goes on top, and my root goes on bottom. So power on top, root on bottom. All right, so we can rewrite any root as the base raised to a fractional exponent. And that's what we're getting ready to do with that x and y up there. All right, next I see a product here. I see an x times a y. I'm going to split those into two logarithms. So I'm going to rewrite it as natural log x, natural log y. Now that square root's still on there. We'll take care of that in a minute. But before I have to do that, I have to be careful because I'm subtracting that entire logarithm here. I'm subtracting all that. So if I split it up into two logs, natural log of square root x minus, plus natural log square root y, because since that's written as a product, I can rewrite it as a sum. I have to be careful and remember that I'm subtracting this entire expression. Since I was subtracting up here, I'm still subtracting it down here. And this negative right here is going to need to be applied to both of those logarithms inside the parentheses. Okay, what does that change? Well, I apply it to the x, and I have minus natural log square root of x, and I apply it to the y, and that negative makes that plus natural log a minus natural log y. I just kind of distribute the negative. So I distribute the negative here, and I distribute the negative over here. It's kind of like multiplying them both by -1. Okay, the last thing I'm going to do is I'm going to rewrite this x and y as fractional exponents because we're getting ready to move that and use that power property. So look at that x. It is being raised to the power of 1. We just don't write the 1. And it has a root of 2. We just don't write the 2. Same thing on the y. It's being raised to the power of 1 and has a root of 2. So I'm going to raise the x to the 1/2 power because that power of 1 goes on top and the root of 2 goes on bottom. Same thing with the y. I'm going to raise it to the 1/2 power. All right, the last thing we're going to do is we're going to move this power, this exponent, to the front. That's that power property rule. Now here's what we have. I did forget to move that 3 up front, so I need to go ahead and do that. All right, and there's our final answer. 3 times the natural log of z minus 1/2 times the natural log of x minus 1/2 times the natural log of y. Notice we just kept going and kept simplifying until our z and our x and our y were alone. They didn't have any roots over them or exponents or anything like that. We just kept simplifying until we had a plain z, a plain x, and a plain y. So that's kind of a rule of thumb. Just keep going and keep using those properties until you remove all the exponents and roots and stuff around them. All right, why don't you guys try this one, work it out. I see a product on top, and then it's being divided by z to the 4th. So I see 3 logarithms coming. I see log x, log y, and log z is how we're going to end up. See if you can figure out how to do it. Use those properties. And here's what I got. First, I took the product and split it into a sum. Now the first thing I did was right here. I wrote it as a difference, and on the next step I took this product and broke it into a sum. And finally I took these exponents and moved them out front. Okay, I see 3 terms here. I see an x, I see a square root of x, I see a z to the 4th, and I see the number 125. So when we get done expanding this, we're going to have 3 logarithms. We're going to have log x, log z, log 125, basically. So let's figure out how that works out. Okay, I start by separating them. The product on top I changed to addition, and divided by 125 I changed to subtraction. Now I got to deal with those exponents. The x has a 1/2 by it, so I'm going to move that 1/2 out front. That z has a 4 by it. I'm going to move that 4 out front. And then we got to talk about this log here. We can actually evaluate that log. Think about it. Our base is 5, so think 5 to what power, I'm going to put a question mark there, equals 125. Well, actually, 5 to the 3rd power equals 125. So if I evaluate this logarithm, all I'm saying is, the question is, what exponent would I have to put on that 5 to get 125? So this logarithm is going to turn into 3, just the number 3. The log base 5 of 125 is the number 3. So we're going to replace that whole expression with the number 3. And there's our final answer showing all the steps. So I changed the x to the 1/2. All right, and then on the next step I moved all the exponents to the front. So I moved the 1/2 to the front, and I moved the 4 to the front. And then finally, this log base 5 of 125, you're basically looking for an exponent. That's what we use logarithms for. We're saying, what is the exponent? They're saying, what exponent can I put on the 5 to get 125? Well, that exponent would be the number 3. So 3 replaces that whole expression, and there's our answer. Okay, now when we're expanding, think about what we did. We changed any multiplication or division that we saw to addition and subtraction, and then we moved the exponents to the front of the expression. Well, what we're getting ready to do now is we're going to take a bunch of expanded logs and we're going to go backwards. They're going to give us a bunch of expanded logarithms, and they're going to ask us to write it as a single logarithm. So we're basically going backwards. So we're going to go backwards on our procedure. First, we're going to move the exponents back where they go, and then change addition and subtraction back to multiplication and division. All right, so we're just reversing the process and going backwards, changing a bunch of logarithms into a single logarithm. All right, look at this one, for instance. 3 log base 2 of t minus 1/3 log base 2 of u plus 4 log base 2 of v. We have 3 logarithms there. We're going to combine them into a single logarithm. So the first thing we're going to do is move our exponents back where they were. So I'm going to put the 3 back on the t as an exponent, and the 1/3 on the u as an exponent, and the 4 on the v as an exponent. All right, now look at the u to the 1/3. That's going to be a root. Remember the 1 on top, that's my power that u is being raised to. And that 3 on the bottom, that's going to be the root that's being taken on u. So u is being raised to the first power, and I'm taking the cube root, or third root of u. All right, I'm going to change that subtraction to division. So I change the subtraction back to division, and I have log base 2 of the t cubed over the cube root of u. And the last thing I'm going to do is I'm going to change that addition back to multiplication. So when I multiply that v, it's going to be multiplied times that t on top. And there's our final answer. So we changed those 3 logarithms back into a single logarithm. And really we only did 2 things. We put the exponents back where they were, and then we changed subtraction and addition back to division and multiplication. Now here's kind of a tricky one. Let's look at this. First thing I'd probably do is eliminate those parentheses. I'd probably distribute this negative and straighten that out first, which changes the 2 log x to negative and the log y to positive. Okay, now I'm going to put the exponents back where they go. The only exponent I see is this 2, so I'm going to put that 2 back where it goes. And then I'll change that subtraction to division, and then my last step will change that, be changing that addition to multiplication. Now notice that I can simplify that 3x over x squared. One of those x's will cancel on top and bottom, leaving me with an x on bottom and a 3 on top. And then, like I said, I'll change that addition to multiplication. So that's 3 over x times y, which is really just 3y over x. So our final answer is log 3y over x. Okay, and the last thing I want to show you is a little practice with change of base formula. So we have 3 logs here that we cannot calculate on the calculator. But if we use the change of base formula and change their base, like the first one, we're going to change it from base 5 to base 10. Second one, we're going to change it from base 50 to base 10. And the third one, we're going to change it from base 3 to base 10. All so that we can calculate these on the calculator. So remember, it's just the log, the log of the big number over the log of the little number, the base. Uh-oh, I wrote that wrong. I wrote the base as a base. It's regular size now. So log base 10 of 37 over log base 10 of 5, which we punch in our calculator, and get 2.2436. You guys try the next one. I got 0.7901. Okay, the last one looks tricky, but it's really not. Just think of that 7/8 as a single number, like the 37 and the 22 above in the 2 problems before that. So we set it up, log of the big number, 7/8, over log of the little number, the base, 3. And just punch that in your calculator. Now just remember to put parentheses around the 7/8 when you put it in the calculator, and it should work out fine. And I got negative 0.1215. Now remember, these that we found, these answers, they're all exponents. We're asking what exponent would I put on the base to get that number. So let's take a closer look at log base 50 of 22. We are saying that 50, the base 50 raised to the 0.7901 is going to give us 22. And if you put that in your calculator, you'll see that it's true.